spastic, ataxic, and dyskinetic cerebral palsy. Children are often born with cerebral palsy, and it varies a lot in magnitude. Some children basically can walk with a walker or something similar, whereas a lot of other children are confined to a wheelchair. There are a lot of wheelchair users. And basically what that means is they need a helper, and there are a lot of activities which they are incapable of performing without assistance, which includes swimming and the playground. Which brings us to our problem statement.
Our problem statement is to design an effective means of allowing children in wheelchairs with cerebral palsy and other related conditions to swing independently.
Now we bring to our feasibility criteria, which is affordability, independence of use, and environmentally compatible. Affordability, we set it to be under $2,000 is the cost of the swing set and the platform swing. Next is independence of use. The child must not be required to use his legs to swing on the swing. And environmentally compatible is that the device does not corrode due to rainwater and other weathering effects.
The merit criteria include affordability, which is cost. We'd like to minimize that ideally. Independence, which is basically the number of steps required to utilize the device, either by the child or the helper of the child. You have durability, which is basically the environmental conditions or the physical conditions, the mechanical stress, for example, that cause the device to fail. Simplicity is the number of moving parts, so how complicated is this design? Are there lots of places where it could fail? And versatility, which basically describes the number of people who could benefit from the design. Basically the three different main classifications of cerebral palsy, and maybe just generally people in wheelchairs.
This brings us to our alternative ideas. The first one is the pulley bar swing system. It uses a platform swing and a pole with a rope attached to a crank. Another person would turn the crank, which would increase the potential energy of the swing, and then release the crank, and the swing would swing back and forth.
The second alternative idea was the pulley bar swing 2, which was a reformulation of the pulley bar swing 1, which was an attempt to simplify the previous pulley bar swing by creating an attachment mechanism which fixed directly to the top of the swing set. We did realize, however, that this created a potential safety concern, and it didn't reduce the cost, and it didn't significantly reduce the complexity like we thought.
The third design is utilizes an electric motor. It's like the other designs, except the child with cerebral palsy can turn the swing off and on at any times. However, the cost was the main concern of this.
Oops, something happened. Sorry about that, you guys. There we are, Rose.
And the third design was the tandem swing. Essentially, it is like the other designs in that it is a wheelchair swing, except in this case, the wheelchair user gets ramped up onto the device closes, and then another child sits opposite of them, and then that child powers the swing back and forth.
So we have our feasibility and merit analysis table. Basically, what we found was that the superior design is the swing liner, which scored 90 compared to the others, which scored 70, 71.25. So it basically what allowed the swing liner to exceed above the other designs was in affordability, durability, and simplicity.
The three subsystems is the line subsystem, seatbelt subsystem, and the path mechanism subsystem. The line subsystem will use two polyurethane sheets and a meshwork of nylon strips. The nylon strips will provide the durability of the subsystem, and this subsystem needs to be comfortable and durable and withstand the forces of the child swing on the swing.
And the next one is the seatbelt subsystem. We chose a 4-point design. It allows for the child to be held in the swing liner much more safely, much more comfortably, and much more securely. The main concern with this is the attachment points. However, when we ran the stress calculations on this, the polyester material well exceeded this, creating a large factor safety.
The final subsystem is the attachment mechanism subsystem, which is consisting of two parts. The first part are Velcro straps which are along the base of the swing liner, and what it does is it prevents relative motion between the actual swing seat and the swing liner. Velcro straps basically go over the swing seat once the swing seat is placed at the bottom of the swing liner, and that's it there. The second part are all these nylon straps which support the weight of the child as the child is leaning back and in the swing liner, and it also maintains the shape of the swing liner.
This brings us to our budget. The cost was around $130, but the cost per design is around $95 due to extra bulk materials being purchased.
It's worth mentioning that the nylon strips and the extra strong thread were itemized in the lining subsystem, but are in fact utilized as well in the seatbelt attachment mechanism subsystem.
And then for this design to work, the swing liner goes on the wheelchair, and then the child sits in the wheelchair throughout the day, and when he wants to go swing, the helper rolls his wheelchair to the swing, slides the swing seat behind him onto the swing liner, and attaches the carabiner clips to the metal chains. Then the user, or the helper, removes the wheelchair and attaches the Velcro that's on the bottom around the seat of the swing.
And what this prevents is an awkward, sometimes dangerous transition between, custom designed swing and a wheelchair. That sort of situation, the kids could fall and hurt themselves. This way, they never actually have to leave the seat. They're just always sitting in it. It's not uncomfortable. They just roll in a wheelchair. We had a demonstration on a newer, more updated set of slides. I think there was a confusion or something. Any questions?
So this doesn't allow the person in the wheelchair to propel themselves, somebody else has to push on the gears them in?
Yeah, so depending on the level of severity of the cerebral palsy, we're focusing on children in a wheelchair, so generally there's always going to be a helper. When you're talking about independence, there's not a lot in the way of improving that situation. So the helper would ultimately push the child to the swing, and it would connect, and then they would move the wheel. So when you're swinging in general, you have a partner, usually that will push you. And on playgrounds, you can almost always find a volunteer who would help someone.
We thought this design would be more fun, more similar to like other children playing on swing grounds instead of just using the platform. Because all of our other ideas were just using platforms, and we wanted to make it closer to what just regular swing on swing for people who are not disabled.
Right, and one concern was isolation. A lot of the times these other solutions tend to be these custom-built rigs, which are not near the rest of the playground's equipment. And in general, there's a helper or something with them, but you don't get that other social interaction. This way, they actually get social interaction with kids on the playground. What's this? It's one of the big benefits.
How much weight does this add to the wheelchair itself? Is it meant to be integrated into the vehicle?
It's entirely fabric, so
I believe the cost of the
It's-
C12 was the most weight.
It's a
added.
total of 10 pounds.
and it's modular